Welcome to the Denver MuleSoft meetup, hosted by the integration lovers at Big Compass. Today we are joined by Tim Hanline from Mule Learning, who will be covering delayed message reprocessing. Keep those objects in order.
So the idea here is that failed transaction commits due to cardinality errors to the target system must be retried n number of times on a delay of X number of seconds. Now, all those are adjustable, of course. All right, so let's go ahead and dig in. So if the retries expire, the message is placed into an error queue and an alert is raised. All right, so those are the real basic requirements we're going to talk about, and then we're going to build at least some of this here, okay? The tricky parts. Now, I wanted to get into what do I mean by referential integrity errors or cardinality errors. And for those of you that are also familiar with Salesforce, this particular entity relationship diagram will look familiar, although I've got 3 circled here. Let's just focus on contract and order. And you'll notice that there's a relationship between contract and order. There's a one-to-many relationship between contract and order. So in other words, contract is a parent and order is the child, okay? So what does this mean? So that means that, let's just say that an order record arrives, and in this case, Salesforce is the target system, okay? So Salesforce, being the target, is going to receive these messages, but let's say that the source system is not, it doesn't have all the intelligence it needs to really determine the cardinality of the target system. It just receives some update and it just sends the message along without much more thought than that. So the idea here is that if the source system sends information about the order and it happens to arrive before the information about the contract, presumably the information on the contract is going to come too in short order. If it hasn't already arrived, it'll actually come maybe a few seconds or a few minutes later, hopefully, right? But when the order message is received, because there's no contract or parent object in this case, Salesforce is going to throw an error because you can't have an order without a contract. So it breaks the rules of referential integrity. And so let's just pretend that's the case. You guys get the idea that a child object arrives before the parent, raises some error, and now we want to wait for the parent to arrive and then reprocess the child. Does that make sense, everyone? With me so far? Okay, so as a matter of fact, this is becoming, for me, actually quite common. So this pattern is, I've needed to use this pattern with a couple of different clients now, which is very interesting. So they're just synchronizing data to Salesforce, and this becomes necessary. All right, cool, good. Thank you, everyone. All right, so here we go. So we're going to write an application, okay, that receives messages from the source system and writes that message to the target system. And the target system is going to either accept the data, which is great, or it's going to reject it because of some error, like cardinality or validation. So if it's a validation error, the validation errors will be processed back to a queue at the source system, and the source system is going to have to deal with it. They're going to have to actually read that message and figure out what went wrong with it and maybe make some corrections. But that's their job, right? But our job, writing this data sync app in MuleSoft, is to reprocess the error if it is a cardinality error. So if it's a cardinality error, or even a system outage error, we'll want to save that message and retry it a few moments later. So what we're going to do is we're going to take that message, that either the system outage error or the cardinality error, and put it into a queue. This will be our retry queue, okay? Although it's a little bit more complex than just a retry queue, and I'll explain why in just a moment. But on some timed interval, it's going to try that again, right? So hopefully the next time a retry happens, then the parent object exists or the system comes back up and the message processes with no problem. But let's just say we set up the number of retries as some random number, 6, okay? Let's just say we've retried 6 times, and if all those retries expire, if the retries expire, then we're going to place the message into a queue, an error queue, expired reprocessing queue, and then raise an alert. So somebody's going to have to know that there's an error in the queue. It tried to process so many times and couldn't. And so that's when we send an alert. But the key here is that we set this up on a delay, right? So we don't just do all the retrays within a few milliseconds. We do this within a few minutes or maybe several minutes, okay? All right, so next. So what we're gonna do, everybody, is we're gonna go ahead and do a walkthrough in which we're gonna set up the main flow for our application, and it's gonna receive a incoming message. In this case, we're just making an HTTP request, although you could have this, the inbound endpoint could be anything, maybe GMS that's gonna read from a queue or whatever the case may be. And we're going to simulate an error. So this is null as a validator, and it's going to always raise an error, right? Okay. So we're going to pretend this is our outbound endpoint that's going to connect to Salesforce, and this is the item that raises the error. Okay. So in this case, it's a validator. It's just always going to raise an error. So that's our simulated outbound endpoint. All right. So if you'd like to follow along with me, I'm going to go over to Studio. And we're going to take great professional risks by just doing this ad hoc and live. All right, so here we go, everyone. Let's go ahead and create a MuleSoft project together, and we'll just call this the reprocessing demo. I'll just abbreviate. Reproc demo. So the reproc demo, and we'll go ahead and click on finish, okay? All right, so we're going to and it's take a few moments, and then we'll create our first flow. We're gonna call it the main flow. Okay, so it'll be a default HTTP listener here, and then we are going to put a transform in here. I'm going to show you how we're going to enrich the incoming message with a retry count, and then we're going to send it over to the try scope to actually simulate that outbound request, that outbound endpoint. All right, so let's go back here to Studio. And I'm running a PC. For those of you running a Mac, you probably were done, a few moments ago, but I have to wait. I think I need a new PC. I might need a gaming PC. Okay, so HTTP listener, everyone. Let's grab an HTTP listener from the palette and just drop it here into the canvas. There we go. And we'll do all the normal cool stuff. Let's go ahead and make sure that we can differentiate between the flows. So let's rename the flow to main flow. Okay. And the HTTP listener, so the flow now is renamed. The HTTP listener will just be the standard default setup. The connector configuration, you can just choose the defaults, perhaps. Let's go ahead and create a new one. It's going to listen on port 8081 by default. So if you want to test the connection, please feel free to do that. Pick a port that works for you and go ahead and click on OK. And the path, let's just make it reproc. /reproc, okay? All right, thanks, Jordan. Thanks, Mana, appreciate that. Thanks, guys. All right. Okay, so with that done, let's go and continue to build out our flow. Let's put our data weave in here. So we'll put our transform message in the middle of the flow here. So there we go. From the palette, grab transform message, put it into the process section of the flow, and then we're going to go ahead and enrich the message now. We're going to enrich the incoming message with a retry count. And I'm going to put the code for this into your chat window, everybody. And I'm not going to type it out. I'm just going to copy and paste it. So there you go. I just put it into the chat window, and I'll put it into my code here as well. And I'll probably want to do a little indentation here to make it more readable, maybe. Lots of warnings everywhere. Just ignore those for now. We're not going to mess with those. But we're just going to leave this now the way it is. So it's going to output to the payload. And we're going to capture the original message or the original payload in the original payload key. And then we're going to add also a retry count, and it'll default to 0. Okay, now let's put a try scope in the flow now. try scope will go here. And now we're going to simulate that outbound endpoint. All right, so this will be a mock outbound endpoint that's going to, we're going to pretend it goes to Salesforce, but it's going to actually be a validator. So it's going to be an is null validation. So grab the validation, go ahead and click on is null and drag that right into the try scope. Is null, there it is. Perfect. Now the is null, what we want it to do is raise a error if the payload is null. In this case, it's not going to be null, so it'll always raise an error, but the value here needs to be payload. Okay. Oh, and by the way, not just payload, but let's go ahead and make it, click on this little function or box here, so that way it switches to actually, translate everything to data weave code, right? And it actually evaluates the payload instead of the string payload, right? There you go. Make sure that is in place. All right, now the error handler, everyone. All right, Eduardo, good. Let's go ahead and add an error handling. Now the error handling, we want to put on error continue here. And the on error continue is going to house and this is going to be our first VM connector, everyone. So let's go ahead and put a VM connector. Now, but we want to actually use the publish and not the publish consume. This is very important. We don't want to wait for a response. We just want to go ahead and publish the message to a queue. So let's go ahead and use publish here. Okay, so just go ahead and put the VM publish into the on error continue. Now we're going to configure this this VM publish here in just a moment. But before we do, let's give it a descriptive name. In this case, it's going to be publish to wait queue. And you're going to ask me, well, Tim, why do we need a wait queue? I thought we were worried about the retry queue. And you'd be right. We are going to use both here. And let me explain why. Okay, so before we set the rest of this up, let's go back to our slides and have a little talk about something. Okay, so what we want to do is actually use two queues, a wait queue and a retry queue. And there's a reason for that. And the reason is we don't want to run the risk, or to be more precise, we want to absolutely minimize the probability that we could cycle through all of the retries in just a few milliseconds, right? We want to have a wait condition. So the objective here is that we don't want the retries to happen all at once, and we want the reprocessing to be delayed. Therefore, we're going to stagger a wait queue and a retry queue, and I'll explain why in just a moment, and it'll all make sense. But just to explain what's going to happen here, the incoming error is going to go into the wait queue, and it's going to wait 15 seconds, and then it's going to cycle over to the retry queue and wait 15 seconds, and then do the retry. Okay, and again, the reason for this is to minimize the chance that there would be an instantaneous retry, expiration of the retries, or near instantaneous, right? And this will make sense here in just a little bit. But what we're going to do here is we're going to set up that VM global element first. We're going to set up two queues, the retry queue and the wait queue, okay? And this is going to be a very key piece of this. Now, Jordan, you asked for some feedback, and I have a little bit, and that is, I'll just be frank. This connection checkbox was not incredibly well understood by me when I read the documentation. And as a matter of fact, I've got to actually credit somebody in our study group, our little Mule Learning community, right, for actually coming up with a solution to this. His name is Mark Knox, real smart guy. And he did a little bit of trial and error and figured this out, but we both weren't able to glean this information from the documentation. So I want to say all that to say it's very important to make sure that this checkbox is checked and this checkbox is checked. And I'm going to go over that again in just a moment as we set this up together. All right, so make sure those are both checked when we do this, and we're going to create 2 queues. There we go. So here we go, everyone. Let's do a walkthrough in which we're going to set up the queues, but we're also going to create another flow, and this is the process wait queue flow. And the idea here is that the scheduler is going to be scheduled to run every 30 seconds, but it's going to be set up on a delay of 15 seconds, whereas the reprocess queue will be set up on a delay of 30 seconds. So there's going to be a 15-second offset between the wait queue and the reprocess queue, okay? So in other words, the wait queue processes 15 seconds after the application starts, and then 15 seconds later, the reprocess queue happens. And again, the scheme is to ensure that we minimize the probability of instantaneously expiring all the retries. So the scheduler will run every 30 seconds, and I'll explain what this is for in just a moment, but this consume with the VM connectors configured correctly then is going to read one message off of the wait queue and then process it to the retry queue, okay? Now with the special setup that I just described, then the consume is actually going to read one message off of the queue when it's prompted to do so, because if you set the VM connector up just a little bit incorrectly, the scheduler will be completely irrelevant, and the message will be picked up from the consume immediately when it gets placed onto the queue. So you don't want that. We want it to be delayed. So we got to set this up just right. All right. Now you're wondering, why do we have a parallel for each loop here, and why do we have a payload array here? And the idea here is, let's just say that we're actually processing a great volume of messages, and maybe the reprocessing queue gets filled with 10, 20, 30, 40, 50, maybe 100 messages at a time, whatever the case, maybe even a few hundred in a very short amount of time. What I want to do is be able to, I'm going to create a blank array here with this payload array. It's just going to be a 100 element blank array. And then I'm going to feed that payload to the parallel for each loop. And the parallel for each loop will then iterate over in multi-threaded fashion asynchronously. It'll iterate over all 100 empty elements. And for every empty element, it's going to execute the consume from wait queue. So it becomes now multi-threaded, and it reads that queue very fast, and it processes it very fast. Okay, so that's the idea there. Also, this on-error continue, it is here for a special reason, because every time the scheduler executes the flow and the consume from wait queue consume element gets executed, if there's not a message on the VM queue, on the wait queue, it raises an error, and that error has to be handled. And that's exactly what this on-error continue does. It handles that error that gets raised if there's an empty queue. Now, I almost would prefer that there's not an error that gets raised with the empty queue, but I can see a good reason for it, so we'll just kind of go with it. The point is, though, we have to handle that error, okay? All right, so we're going to go ahead and set up the VM connector, and we're also going to go ahead and set up this process wait queue flow. So let's do this together, everybody. I'm going to, back here at my main flow, the publish is publish to wait queue, and I want to create that connector configuration here. So I'll go ahead and click on the plus sign here to add a connector configuration or a global element for VM. And remember the important part here, connection gets checked, so does reconnection, okay? And also the queues. We have to define 2 queues, the wait queue and the reprocessing queue. And we really do want those queues to be persistent queues. And for those of you that might not know why, let me explain. All right, so we're going to choose inline, edit inline, and we're going to create a queue, 2 of them actually. The first one will be the wait queue. And the type will not be transient, but it'll be persistent. Why? Well, because then the message actually gets written to the disk. And that becomes important because if the application suddenly experiences an outage, you don't want all the messages that are in the queue to be vaporized. You don't want them to vanish. You want them to be there waiting for you when the application comes back up. Or let's just say the Mule runtime crashes. However unlikely that might be, right? You would want those messages to be there when the Mule runtime and the application come back up, okay? So we're gonna be persistent queues, and that's all we need right there. So the wait queue, make it persistent. We'll do the same thing for the reprocessing queue, so we'll add another one, and this will be reproc queue, okay? And it also will be persistent. And click on finish. So at the end here, we should have 2 queues, a wait queue and a reproc queue, both of them persistent. And if you got that, you got it all. And let me go to the questions here. Okay. Vikas asks, is there a way to get number of messages in a queue and then run for each that many number of times? The answer is there might be, but I don't have that in the lesson. So I think that probably would be ideal, because, but reading the number of messages from the queue, I'd have to research that one a little bit. Sujatha says, could you explain the connection and reconnection checkboxes here? Yeah, so the connection, and quite frankly, I think the reconnection we could do without, but this is the way my application works. But the point is that with connection, that is the way that we tell the consume to not execute until the scheduler tells it to. Because otherwise, the consume, even though it's in the middle of a flow, doesn't care. It's just going to immediately read that message off of the queue without the scheduler prompting it to do so. All right, now it's a little bit nuanced and it's not clear in the documentation, like I mentioned, but this is the way to make it work. So there you go. Okay, also, runtime manager front end shows number of pending messages in the queue. So there's, yeah, so Vikas, you're absolutely right. I'm pretty sure there's got to be a way out there to read the number of messages. I just don't have a good answer for you on how to right now. So, but research it and send me the answer, if you don't mind. You bet. Thanks, bud. But not right now. Wait till later. Okay. Let's go ahead and click on OK, everyone. And that takes care of our global element for the VM connector. And now the queue name, in this case, will be wait queue. In other words, we want to publish to the wait queue. Okay. And there we go. Let's go back and check our work. So again, this is the VM connector. Now this isNull is a validator. Let's go back and take another look at that. And it just makes sure that the payload is not null. If it's null, it raises an error. So that basically means it's always going to raise an error. Okay, now the walkthrough here, as you recall, is to create this process wait queue flow. And remember, the objective here is to get this consume from wait queue to execute only when the scheduler tells it to do so. Let's go ahead and set it up. So we're going to grab a scheduler from the palette and go ahead and put that into the canvas here, and that'll create our new flow. And this new flow, let's go ahead and give it an appropriate name. Let's call it the process wait queue flow. And now the scheduler needs to be set up in a very precise way as well, okay? So we're going to go to the scheduler and we're going to set this up to run on a fixed frequency. And that frequency is going to be, let's say 30 seconds, so 30,000 milliseconds, and the start delay, now this is an important part, is 15,000 milliseconds or 15 seconds. So, all right, because remember, we want the wait process to execute, and then 15 seconds later, we want the reprocessing queue to execute. And that's all we need right there. All right, now we're going to set up this empty 100 element array. You can make it more elements than that, but let's just go ahead and I'm going to give you the code for that. So I want to go to the palette now and grab a transform message and put the transform message into the flow. There we go. And let me give you the code for it. So I'm going to put the code into your chat window again. Okay. So the code is going to create an empty 100 element array. Now, everyone, when I want to give you this solution, I want to just make a caveat and say, look, this is a solution to the problem, and it's, I'm guessing, not the only solution. But anyway, this one works. So we're going to give this one an appropriate name. This is going to be the payload array, okay? And again, just an array of 100 empty elements is all we need to get this parallel for each loop to work, okay? All right, now with the payload array created, we're going to put a parallel for each loop into the flow. And remember that the parallel for each loop is just like a for each loop, and it behaves very similarly, except it's multi-threaded. So it's going to iterate over our 100 element array very, very quickly in multiple threads. So it's going to do so asynchronously. And inside the parallel for each loop, oh, actually, let's go ahead and configure it. So we, of course, want the parallel for each loop to iterate over the payload in this case. So let's go ahead and select the switch to expression mode and then put the payload in there. So again, the payload was set to an array of 100 empty elements. So that's our collection. Now inside the parallel for each loop, everyone, we want to go ahead and put our try scope. There's our try scope, okay? And the try scope's all we need. And now this is not optional, but it works. Let me just go ahead and advise you to go ahead and do it. So I'm going to put an async scope in here. Probably not necessary, but let's go ahead and do it. So an async scope inside the try scope. Okay, and we'll save that for a little bit later. But right before the async scope, what we really want to do is put that that consume. So go to the palette again and grab a VM consume. And put that right before the async scope here. And now remember the consume here, it has to use the connector that we've already configured. And with that configuration, it's going to wait until it's told to read one message off of the queue, okay? Now the queue name needs to be wait queue. So we want it to read off of the wait queue. It's going to read just one message. And now the timing also it becomes necessary to be very precise about this. And we want the timeout to not exceed, say, 50 milliseconds. And again, all of this is tuned in an effort to keep everything from happening all at once, right? The retries from happening all at once. Okay, so 50 milliseconds, and I think that's all we need right there. Now, let me go back to the consume. So again, wait queue 50 milliseconds, that's all we need. And the next thing we need to do is actually check to make sure that the payload has a retry count that's not expired. So it's at this point we want to go ahead and try the retry count. Anyway, yeah, that works. So we're going to use the choice router, everybody. So the choice router is going to test that retry count, and it's going to say, hey, you know, if the retry counts have expired, we're just going to stop processing it. All right, so we're going to set up that logic right here. But I'm going to put this async scope inside the when condition. Let me go ahead and do that now. All right. So I've got to now configure the when condition for my choice router. And let me give you that code. You probably saw it on the slide, but there it is. Okay, I just put it into your chat window. And again, we want to select the expression mode here. Make sure it's in expression mode, and then go ahead and paste that code in there. So what we want to do is, if the retry count is less than 6, so, and I made everything everything's hard coded here, everyone. But typically, if we set this in a production ready application, 6 wouldn't be hard coded. It would go into a YAML file or some properties file. All right, so we got a question here. Hyphens after, oh, add 3 hyphens after the output. Yeah, so probably could actually go down that road, Jordan, but I think this will work. So it works. So the expression here is going to be sufficient for what we need. All right, now if the condition resolves to true, which means we haven't expired the retry counts, we want to go ahead and place the message into the reprocessing queue. So let's go ahead and set that up, and it's going to be a VM connector again, and this is going to publish. We're going to put the published VM connector, or outbound endpoint, I should say, into the async scope, and it's going to choose our connector configuration for us, which is exactly what we need. And the only thing we need to provide it here is the queue name. So the queue name is going to be reproc queue, and there you go. Okay. Let me check the timeouts here to make sure everything else is good. Now the timeouts do matter. Okay, so again, I've tested everything and it works with the precise timeouts. So I'm going to set the timeout to 50 milliseconds, everyone. Okay, so publish, the queue name is reproc, timeout 50 milliseconds, and you should be good to go with that. And we want to give it a name. Let's give it a descriptive name, and this is going to be published to the reproc queue. Okay, there we go. And also the consume. Let's go make sure that we have the correct timeouts for the consume. This one may not be as critical, but let's go ahead and make sure the consume is 50 milliseconds, and it is. Okay, good. Okay, so that's all we need right there, everyone. Now notice the error handling is here. And again, the consume is going to raise an error if the queue is empty. So we want to handle that error. And there's a trick to making the error handling less chatty. So the on error continue here, let's go ahead and put that here into the error handler, okay? And the on error continue, we need to select the type. Now we can do a search for the type here, but it's VM empty queue. So if you click on the little search window, you'll be able to see VM empty queue in the list of options. Just go ahead and select that one. There you go. Now hold on right there, everyone. Let's go back to the slides for just a moment. And we want to make a point about something. So the error is raised every time the queue is empty. So I just want to emphasize that point. It's an important one. So how we configure the on error continue, it really determines how chatty the errors will be, how much stuff it'll pack into the application log file. And we don't really want it to be very chatty because it's going to execute every 30 seconds, right? And so we want to minimize the chattiness by disabling enable notifications and also log exceptions. So we'll make those both false. So back here in Studio, let's go ahead and click on enable notifications and log exceptions. So both of those settings should be unchecked, and this is going to cut down on the amount of information that's being written to the application log file. And there we go. Okay, everyone, we're almost there. We've got one more flow to go, and then we'll test it out, okay? So let's go back to the slides. Okay, and then the next walkthrough is to set up the final flow, and that is the reprocess flow. And again, it's set up on a scheduler, same principles as before. We've got an array of 100 elements, all of them empty elements, and then we're going to, using the same principles, consume from the retry queue this time, and then it's going to call the main flow. All right, so it's going to read that message off of the queue, execute the main flow, and then hopefully this time it processes correctly. But all the same principles apply with this particular flow. Let's go ahead and set it up. So in Studio, everyone, we'll go ahead and, with another scheduler, we're going to give this flow a name that's appropriate, and it'll be reprocess flow. Or, you know, execute, I don't know, whatever you want to call it, but reprocess flow is good enough. And then the scheduler needs to be set up very similar to the previous one. So it is fixed frequency. The frequency is going to be 30,000 milliseconds, 30 seconds. And the start delay is important. It also is going to be 30,000. Okay, because remember, the wait queue executes, and then the reprocessing queue executes 15 seconds later, so they're staggered. Okay, again, minimizing the chance that you're going to expire all the retries in a few milliseconds. Okay, so there you go. There's your scheduler. And again, next step is that transform message to create the empty array. So we'll get that set up again here too. Again, the empty array is for the parallel for each loop. Here's that code again. It's the same code, and if you want to, you know, it's not optimized for reuse. It's just the same code. We'll put that into your chat window too. Right? So, you know, usually when we want to use the same code for data weave, we save the code to a file and reuse the file. You get the idea, but we're built for speed right now. Sujatha. Okay, so parallel for each loop. And again, the parallel for each loop is going to read from the payload. Again, we've got to switch to expression mode and just type out payload here. And inside the parallel for each loop, we'll put a try scope. Okay. Inside the try scope, we're also going to put another consume, and this time it's going to consume from the reproc queue. All right, we want a VM consume, not a, here, actually, let me search for VM instead. There we go, VM consume, so we don't get confused. And it's going to consume from the reproc queue. Okay. Again, the queue name, reproc queue. The timeout, again, very important, 50 milliseconds. And now we're going to go ahead and put in our flow reference back to the main flow. Okay, so we want to put that right inside the try scope. That's fine. And it's going to execute the main flow now. So that, of course, has our outbound endpoint. And there we go. Okay. So with the flow reference configured, we want to complete this by setting up the error handling. Okay. So the error handling has to have, again, the same as before, on error continue. And we've got to be testing for the empty queue. So we'll put the on error continue in there. And the type, we're going to do a search. Again, select the VM empty queue. And again, we want to make those less chatty. So we're going to disable enabled notifications and log exception, uncheck those both. Okay. Now let's do a quick save so that way we don't lose our work. All right, let me know if I can repeat any step for you. Let's go back to the slides. So now that our walkthrough is complete for our reprocess flow, we're almost there, okay? Now, the last step here, everyone, I'd like you to go ahead and insert some loggers into various places in the application. I'm going to talk you through all this. And what this is going to do is it's going to allow our application log file to tell this nice story for us as we're watching it execute. So you can actually look at the application log file and actually see messages going through each queue and the retries and so on. So that'll make it more interesting to watch. All right, so we're going to go ahead and put these loggers into the application, everyone. And we're going to start with the main processing flow. Let's go back up to the main processing flow. And then we'll go ahead and go right down the line here and put in some loggers. And the first logger is going to go into just the first processor in the flow right before the transform message. And it's going to get this code here that I'm going to put into your chat window. Okay, so I just put that in the chat window. So let me go ahead and do this here. So logger, we're going to put that logger right here, and I'm going to give it an appropriate name. So this is going to be point main flow. In other words, I want to tell, at what point of the process we are. Anyway, we're going to switch over to expression mode, and we're going to paste the code that I just sent you right in there. Okay, so that should work out splendidly. All right, now on the next flow, we're going to put some loggers in here as well. A couple of them, 3 of them actually. And the first one is going to be at the very beginning of the flow. So again, logger at the very beginning of the flow. And we're going to name it point process wait queue. Let me give it the name of the flow. And the code is going to be a little bit different this time, okay? It's a little bit more simple. Again, in expression mode, I'll put the code into your chat window. We just wanted to tell us that it's at this particular point in the process, and we wanted to tell us the timestamp, okay? Now, the next 2 loggers that go into the flow, one of them goes right before the publish to reproc queue, okay? And we're going to give it, again, an appropriate name. Point wait queue processing. Let me give you the code for this one. Similar to the first, I wanted to output the payload, again, in expression mode, and then go ahead and paste that into the window. We want it to be a JSON output. We want it to tell it where it is in the process, what the date timestamp is. We want it to be accurate to the millisecond, and also what is the payload at that point. So real simple. And there is one more logger we want to put into this flow, and that's into the default scope. And this is what happens when all the retries are expired. So the logger will go right in here, and this is going to be named retries expired. And the code we want to go in there is going to be this. So again, it's going to tell us this nice, cool little story as it executes. How are we doing on time here? Ooh, we're almost at an hour. So almost done. We're going to test it here, everyone. All right. Okay, so there's the loggers for our second flow, the process wait queue flow. And for the last one here, it's a couple of loggers. Let's go ahead and move through that rather quickly. Very similar to the first one. There's a logger at the beginning of the flow. It tells us that this flow is executing. Let's call this the reproc flow, point reproc flow, and here's the code for it. Here we go. I'll put the code into the chat window. And there we go. Oh, and the name of this, point reproc. Something like that. Name doesn't matter too much. But the last logger goes right before the main flow reference, and it's going to tell us that the error is reprocessing, okay? So that code is going to look like this. Oh, yeah. And there you go, everyone. So again, expression mode. Okay. And with all of that, I know that's a lot of coding without a lot of testing. So we are going to go ahead and test it. So the application should be ready to test at this point. Let's see if we've done everything correctly. And if we haven't, we'll just cheat and use the right code. So everyone, when we do the test, we're going to do the test from Postman. It's going to be a simple HTTP request. And so let me give you all a test message. So what I'd like to do is enumerate the messages. So the first one will be message 0. Okay, and that's the HTTP request that we're going to send. Now let's go ahead and I'm going to go ahead and start the application in debug mode. Now, does the application ever deploy on the first attempt when you've done that much code? For me, rarely. Anyway, so let's try it. Now, in the past, everyone, I want to let you know something. When I've tried to actually deploy the code, I get a failed deployment because of the sequence in which the try scope appears. Actually, it's the sequence in which the on-error continue appears within the try scope. On occasion, and I don't know why, it actually tries to sneak the on-error continue near the top of the try block in the XML code. And for some reason, when it's not at the bottom, we get errors. So we may have to tweak some XML code in order to get it to work. But anyway, we'll get to that if we need to. But you can see for me, it deployed immediately. So good. With the deployed status, we're going to go ahead and execute the test. We'll send one test through. Hey, Jordan. Yeah, happens all the time to me. You know what? I swear I'm going to. So check this out. Before I actually send the message, it says it's the process wait queue. So that flow is trying to execute. Nothing found. And soon we'll see the same for the reproc queue. But let me go ahead and click on send here. And that's going to send my first message. We're just going to watch this actually go through the flow. And you can see right now it actually raised an error. So I got to figure out why it raised the error. So in the consume, why did it raise an error? Try to consume messages, but was empty after 50 milliseconds. Oh, you know what? My apologies. I think when we're debugging everyone, we want to turn off. So check this out, everyone. You may know this, may not, but we want to disable the error breakpoints. So in other words, when an error occurs, we want the application to not stop. So I'm going to unselect this and then go back to my debugger and then hit resume. And of course, it's not going to cooperate. So I'm going to have to stop the application and maybe I'll just run it. Stopping the application. And this time, instead of debugging it, we're going to run it, although it might have worked in debug mode. I just want to test it at this point. So also, I noticed for screens that I use that don't have a lot of real estate, when I'm actually executing debug mode or I'm looking at the debug perspective, I like to move the debugger window from the top to the bottom here, but it just gives me a little bit more real estate to work with. So it's just a preference. Okay, let's see if we can get it to deploy and then tell that little story. Okay, good. So with the deployed status, let's watch the console now. And we'll go ahead and send that request once more. So send. And we should see the application go through. Okay, so now notice that it went into the wait queue, retry count 0, okay? And then what we should see is 15 seconds later, it'll go into the reprocessing queue. Yep, processing retry queue. So it went into the main queue, main flow immediately. So you can see the time here. It's actually in the logger, but it's also here. So just a few milliseconds later, it went right into the main flow, and it executed, and it went again into the wait queue. And then, whoops, that was right here. The wait queue, now the retry count is 1, and it will try to reprocess again and error it out. We're going to go back into the wait queue, and retry count is 2 now. And we're actually going to see that this is going to try 6 times, and then it'll ultimately just fail. Now, to kind of make it more exciting here, everyone, what I'll do is I want to send several messages through this process at once. So I'm going to change in my request here. Message will be, I'll change that to 1 to make it distinct from the other, and hit send. And then maybe I'll do the same. I'll send another one, 2, and then send, and maybe even 3, and then send. And the thing is, I can go and watch it. I can watch it actually, I can watch all the messages go through here. Yeah, so message 3 is on retry count 0. Okay, so a question that just came in: how do you catch or identify integrity errors from all Salesforce errors? So there's an error that you can capture from the Salesforce connector. It's like the create connector, and Shoot, I'd probably have to get you the code for that. But that's a little bit outside the scope of this one, Vikas. So message 0 is already up to retry count 5. So it's going to try one more time, and then it's going to fail. And then you can see it sort of pop off the list. So anyway, there it is, everyone. So it's now processing on a delayed reprocessing, right? And it's retrying messages every 30 seconds. See, message 3 is already on its retry. And then eventually it's going to, retry count will expire and it'll, pop off the stack. So there you go. Message 0 is already on retry count 6, so we should see it pop off the stack here in just a moment. Yep, message 3 is on retry count 3. So yeah, these last 3 messages, 1, 2, 3, they're all on retry count 3. But anyway, there you go.